Good morning, everyone. I'm just going to quickly plug in my earphones. Excellent. I've got people responding to me. My name is Richmond, and I am one of the math teachers here at Mathspace. I don't know if you can see my shirt. It's kind of back to front as well. And today, we're going to be doing a revision lesson on fractions. Now, with me is the ever so awesome Yasmin. Do you want to say hello, Yasmin?
Hi, everyone.
And Yaz is basically going to help us with sorting out questions in the chat. And so if you've got anything that you want to ask or you need help with anything, just let Yasmin know. Just in terms of some housekeeping, can we please make sure that the chat just kind of stays on topic and just be polite and really respectful to everyone that's on there, please. Now, just before we start, in today's lesson, we're going to be doing a quizzes. So different to Kahoot last time, just wanted to mix it up a little bit and change it up. So if you haven't already, can you please go to www.quiziz, that's QUIZIZZ.com, and then do /join. Right, so if you have another device, go grab that and jump on that website on your other device. Otherwise, if you only have one laptop or something like that, just split your screen up so that you've got both. Okay, so let me quickly show you. Someone said, what's the website? Let me show you. Hang on a second. Here we go. Not this one. Not that one. Not that one. This one. Joinmyquiz.com. Oh, it's not even the right one. Sorry, I've told you the wrong site. When you're in there, what I want you to do is go to 018251. Put in that PIN. Join it up. Oh, there we go. We got someone in there already. Now, this is a little bit different to a Kahoot, just to let you know. Basically, you just do all the questions. It's about 10 of them. You do all of them as quick as you can. I'm going to give everyone 10 minutes to do these questions. And then at the end of 10 minutes, we're going to have a chat about some of the answers. Now, it's actually a little bit different. There's like power-ups. There's you're basically racing against yourself, but as you do it, you'll kind of see how you compare to other people as we go. So I hope you guys have fun. Now, there are currently 60 people in this session at the moment. 34 people signed up. I'm going to give you another maybe 2 minutes to get in. And if you can't get in, then do you know what I will do actually? I will go through the solution to my little puzzle that I gave you at the end of last session, which was, can you arrange the numbers 1 through 15 in a sequence of numbers so that any two adjacent numbers, meaning any two numbers that are next to each other, always sum to a square number? Now, remember, a square number is something times something, and that those two somethings are the same thing. So 2 times 2, 4 times 4. And when you multiply them together, that answer is a square number. So for example, 1 times 1 is 1, 2 times 2 is 4. So 1 and 4 are both square numbers. And I'm going to show you, this is one possible solution. You ready? I don't know if you can see my camera. This is one. Oh, it's back to front. That doesn't help. A couple of people have shown me their answers as well. I'm just going to stop sharing for a second. A couple of people have shown me their answers as well, and I'm just going to bring up their answers and type it into the chat. Or actually, why don't you, if you've got an answer for last week's puzzle, can you type your answer into the chat? I'm going to type mine into the chat. There's lots of different answers. And what's really cool about this one is that there's a whole what is it? Theme, no, a topic of mathematics that you could potentially use, which is really cool and different, and I want to show you that. I'm just trying to hastily type in my answer. Sorry, everyone. All right, this was one of my answers. Oh, Annabelle, you got exactly the same one as me. So let me quickly show you what this answer is. So hang on a second. All right. So one really cool way to find the answer was to draw a bit of a diagram. Like you could have done guess and check and just kept going, okay, what do I need to do? But let's say I'm going to start with the number 1. And I know that 1 can only add to certain other numbers to create a square number. Now, if my numbers are, if my square numbers are 1, 4, 9, 16, they're really the only numbers that I can add to it. So I know I can add to this one 15. So I'm going to draw a 15 here and put a circle around it. And I'm going to connect these two together to represent that when I add them together, that's going to give me a square number. There's a couple of other possibilities as well. I could potentially have 3 as a square number because 1 and 3 gives me 4. So that's also a square number. And then the last possibility here is 8. Because 1 and 8 gives me 9. So 1 actually has lots of different possibilities of becoming a square number. But if I have a look at the other ones, the only number that I can add to 15 to give me a square number is 1. So, oh, well, actually I lied because there's a bigger square number, which is 25. So I can actually add to 15, 10 or 1, and both of those will give me a square number. So what else could add to 10? Well, I could get to 16 by adding 6. So that could work. And what else could I have in there? Nothing else. Not for 10 anyway. I could have 15. So I've already got those. What could I add to 6? I could add 9 to 6 to get me to oh, no, I can't. I can't have 9. That'll give me 15. What will give me a square number? How do I get my pointer back? I could add 10. What's the other one? 3. 3 gets me to 9. 9 is also a square number because 3 times 3 is 9. So I've got 3. Oh, 3's over there. So I've got this one here. Right. So notice that I've got myself a little bit of a loop now. What else could I do? So what joins them from 8? Well, 8, I could have 1 to get me to 9. What else would get me to 16? Is 8, so I can't do that one. What else would get me to 25? I should really know this. 7. Right? So if I keep doing this, what I'm going to do is I'm going to create a bit of a 8 and 7 is 15. What am I doing? But if I draw this out, this is what we call a network. And what I want to be able to do is find a way to try and get through all of my little numbers in one go. So at the moment, one of my pathways through, it looks like this. I'm trying to change my color. I don't know. Here we go. Change color. I can go out that way. And that'll have like all my numbers connected. And this kind of technique is what we call graph theory. It's really cool. It's really different to what just normal guessing checking, but it's a really nifty way to kind of solve this problem. All right, now I'm going to call that quits for today, just because I want to get into this quiz. So let me jump into here. Okay, you ready? Oh, 50 people in. This is going to be fun. What about the other 15 people? You joining? Join myquiz.com if you want to join. All right, ready? We're going to start. So remember, this is all about fractions. You just do it in your own time. You're not waiting for anyone. You just go. I think you can kind of join afterwards anyway. So let's go. All right. All right. So this question should have appeared in your screen. I've got some really loud sound at the moment. Oh my goodness. How do I turn this off? Apple takes the lead. First question in. And, oh, interesting. Who's getting them right and wrong? We've got 23, 23. I don't know what these numbers mean. I'm going to figure this out. This is the first time I'm using it, so really I'm experimenting with you guys. I really like this name, Wasabi Gamji. Oh, 5 people on a streak. Now, if you still want to join, go to joinmyquiz.com, I think it was. Or you can also go to quiziz.com/join, type in this game code, and you can join our game as well. Oh my goodness, people are going nuts. Some people haven't started yet. Wow, this is cool. So how many questions are there in total? I think there are 10 questions in total. I've left the hardest for last. At the moment, 36 people know what the top part of a fraction is called. Now, I'm really, really sorry if there are any wrong answers in here. I checked it. I checked my quiz. All right. So we're probably about a couple of minutes in. I'm probably going to give you all about maybe 5 more minutes. See how we go. Oh, perfect score. Yam and how do you say this word? Is that achai? Akai? Someone raise their hand. Talk to me. Talk to me in the chat. I'm just trying to see who raised their hand. Ooh. Oliver, you okay? Ella, you okay? What's up? Talk to us in the chat. If you can't play, you're just going to have to just watch for now. We're nearly done anyway. Ooh. Yam on an 8-question win streak. 9-question win streak. Can Yam get a perfect score? Oh, some people have already finished. So I can see fractions is a pretty tough topic. Oh, turmeric, get in there. All right. We're going to go for a couple more minutes, maybe 2 or 3 more minutes. And, oh, perfect score, Yam. Well, what does the blue mean? Maybe you're on a 4-question win streak? Don't know. All right. I'm going to give you another minute, 60 seconds. And if you haven't finished, that's okay. We're just having a bit of fun. I'm going to roll through the questions in a tick. Now, my sense of time is completely distorted, so I'm just really guessing here, but I'm going to give you another 30 seconds. Get in as many questions as you can. All right, 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. And I'm just going to end the game there. Boom. All right. Now, hey, I didn't want to do this. Who was the winner? Yeah, I'm killing it. Achai second, Raspberry third. Well done, everyone. Great job. Some really good results there. Now, I actually want to go through the questions. How do I do that? Here we go. Yeah, there we go. All right. So, first question. There are 2 parts to a fraction. The number in the top part of the fraction is called the numerator. I think spelling didn't make a difference here. So unfortunately, if you knew the right word but couldn't spell it, sorry. But yeah, the top one's called the numerator. Anyone know what the bottom one's called? What's the bottom number in a fraction called? Type it in the chat. Denominator. Excellent. All right. Part 2. Oh, I really can't see that. Which of the following letters represents the fraction 3/4? Now, this is a number line. And on the number line, you've got 0, 1 in the middle, and 2 at the end. So any of these kind of little points over here are a number greater than 1. So it can't be anywhere. It can't be C or D. So in between here, in between 0 and 1, we've got these little ticks. Now, between 0 and 1, it's actually cut up into 4 equal sections. 1, 2, 3, 4. And so each of this A here is actually 1/4. The middle one's 2/4 or a half, and the third one is 3/4. So the answer is B. Determine which sign, when placed in the box. Oh, sorry, skipped it. Which placed in the box in between the two fractions makes this statement true. Now, first of all, you need to know what these two symbols mean. This one is a less than sign. This one is a greater than sign. And really, the only thing you need to know is if you imagine the sign as a mouth, it eats the bigger number, right? So the open part of the mouth, that's a really terrible, like really hard drawing, really small drawing, right? So you want the mouth to eat the bigger number. So you got to just ask yourself, is a 12th bigger or is a 9th bigger? So the way to answer this is, well, you think about it. If you had one cake and you cut up into 9 pieces, would each of those pieces be bigger or smaller than if you took a whole cake and cut up into 12 pieces and had one of those 12 pieces? Now, obviously, the smaller the number on the denominator, if the top numbers are the same, then the smaller the number on the bottom is going to be bigger, right? 1/9 is bigger than a 12th. Just like a half is bigger than a quarter, right? You want half a cake. You don't want a quarter of a cake. Well, I guess it depends how much you want to eat, I guess. So in this particular case, 1/9 is greater than, that's a terrible greater than sign, a 12th, right? So you want it that way. Okay. Let me clear this and keep going. Determine whether the following number statement is true or false. So this one says, is 13/20 less than, so this is a less than sign, 18/20. Now, very simple, very similar, I should say, sorry. In this particular case, the top numbers aren't the same, the bottom numbers are the same. So really, we're able to compare these directly by just comparing the top numbers. Is if you have something cut up into 20 pieces and you've got 13 of them, is that bigger or smaller than if you've got something cut up into 20 pieces and you've got 18 of them? And the answer is, it's true. 13/20 is less than 18/20. Okay, evaluate the following sum, leaving your answers in its simplest form. Now, these ones take a bit of time, but off the top of your head, because when you're adding or subtracting fractions, remember the only thing you need to do is make sure that the bottom numbers are the same. If they're the same, then you can just add the top numbers together, but then you keep the bottom numbers the same. It's like saying, well, if I've got 3/5 and I'm adding another 5th, because they're both fifths, I can just figure out how many fifths I have altogether. So 3/5 and 1/5, how many fifths do I have altogether? Well, 3 and 1 is 4, so it's 4/5. All right, next one. Evaluate the following difference, leaving your answer in its simplest form. Now, 2 parts to this. You've got to evaluate the difference and then make sure it's simple. What does it mean to be simple? It means the fraction needs to not have any common factors in the numerator and the denominator. It has to be the smallest numbers possible. So if we look at this, 8/10 take 2/5. Remember, you cannot add or subtract things that have different denominators. I can't add or subtract tenths with fifths. I can only add or subtract tenths with tenths or fifths with fifths. So I actually have to make them the same denominators. Now, how do I do that? I do this, right? I can change this fraction into what we call an equivalent fraction. An equivalent fraction means it's the same amount, but just different numbers on the top and bottom. Now, how do I make that an equivalent fraction? Remember, I can multiply the top and bottom by any number that's the same, and it'll be an equivalent fraction. So for example, if I multiply the top and bottom by 2, even though I'm changing the numbers, the value will still be the same. So if I've got 2 times 2, well, that's 4. And if I've got 5 times 2, that's 10. So 4/10 is the same as 2/5, right? If I took a cake, divided up into 10 equal pieces, and took 4 of them, it's the same as dividing a cake up into 5 equal pieces and only taking 2 of them, right? So because I've now got 8/10 and I've got 4/10, I can now do this subtraction because they're the same type of fraction. So I just go, okay, what's 8 take 4? Well, 8/10 take 4/10 is 4/10. And that's not the final answer, right? And the reason why it's not the final answer is because it's not in its simplest form. So actually 2 things you had to do here. How do I make it into its simplest form? Well, then I've now got to look at this fraction and say, can I find any common factors in the 4 and the 10? And the answer is, yeah, you can, because both 4 and 10 are even numbers. So I know that 2 is a factor of at least 4 and 10. Now, okay, let's go back. We talked about factors last week, but I haven't talked about this week. So let's just go back over it again. What is a factor? A factor is a number that divides evenly into this big number. So for example, 1 divides evenly into 4 because 4 divided by 1 is 4. Similarly, I know that 1 and itself will always divide into it evenly. So 4 is also a factor because 4 divided by 4 goes once, right? So 1 and 4 are both factors. To find all my other factors, I check. What's the next number after 1? 2. Does 2 go into 4? Yeah, it does. 4 divided by 2 is 2. So 2 times 2 is 4. So that means 2 is a factor. And now I've got all of my factors of 4, 1, 2, and 4. These are the only numbers which divide evenly into 4. If I have a look at 10, what numbers go into 10? Well, 1 goes into 10. 10 goes into 10, right? Because 10 divided by 10 is 1, and 10 divided by 1 is 10, right? So both of them divide evenly. What else goes into 10? Does 2 go into 10? I check. Yes, it does. 2 goes into 10 5 times. So that means 5 is also a factor of 10 because 10 divided by 5 is 2, right? So I check. So 1, 2, 5, and 10 are my factors so far. I check the next number after 2. Does 3 go into 10? 3, 6, 9, 12. 3 doesn't go evenly into 10. I check the next number after 3, which is 4. 4, 8, 12. 4 also doesn't go evenly to 10. So these are my factors of 10. Now notice that the common factor between them, the highest one, the biggest one, is 2. So that's telling me that if I can divide both 10 and 4 by 2 and make my fraction smaller. So that means that 4 divided by 2 is 2. 10 divided by 2 is 5. And so the smallest, the simplest answer is 2/5. So lots of people got tricked here and picked 4/10, had to simplify down to 2/5. All right, whoa, chat's blowing up. All right. Now remember, if you've got a question that you need me to answer, type it into the Q&A. The chat just goes way too fast. There's too many people talking. So put it into the Q&A section and we'll go from there. All right, let's have a look. Clear my drawings. All right, let's go. Evaluate the following, leaving your answer in its simplest form. So same thing. We're doing the same thing, but subtraction. They're different denominators, meaning we're trying to subtract different fractions, different types of fractions. We can't do that. We've got to subtract the same type of fraction. Now, we've either got to make them thirds, make them both halves. If we can't do that, we want to make them both the same, another type of fraction. Now, notice that I can't directly make halves into thirds very easily. And I can't do the same thing. I can't make thirds into halves very easily. So I'm going to have to make them both a different type of fraction. The question is what fraction should I make them? And the answer is I need to make them a fraction that is the lowest common multiple of 2 and 3. Now, what are the multiples of 2? Multiples of 2 are 2, 4. Oh, I forgot. I keep forgetting that I can write in this. 6, 8, 10, right? The multiples are literally your times tables. So the multiples of 2 are literally your times tables of 2. What are the multiples of 3? Well, you've got 3, 6, 9, 12. And these just keep going on, right? Now, again, the multiples of 3 are just your times tables of 3. What I want to figure out is what is the lowest common multiple between 2 and 3? And I can see here that the lowest common multiple is 6. So I want to make these both fractions out of 6. So I know, okay, I want to make 2/3 into a fraction out of 6, and I want to take away a half that's also a fraction out of 6. So I'm going to make 2/3 into an equivalent fraction out of 6, and I'm going to make a half an equivalent fraction that's out of 6. Now remember, how do I make an equivalent fraction? I multiply the top and bottom by the same number. So to think about this, I want to multiply 2/3 by the same number on top and bottom. I want to get 3 to 6. So I have to multiply 3 by 2 to make it into 6. So that I want to do the same to the top number, right? Now, the reason why I'm multiplying top and bottom by the same number is because if I multiply by 2 over 2, remember that 2, this is getting really messy now. Remember that 2 over 2 is just 1. So I'm just multiplying that fraction by 1, and I'm not changing it at all. I'm not changing the value. I'm just changing the numbers in the fraction. So 2 times 2 is 4. So that's telling me that 4/6 is the same as 2/3. On the second part, a half. How do I go? Let me just erase some of this because it is crazy busy right now on this screen. Yeah. Let me get rid of this. Okay. So I want to go from a half to a 6. I'm on my arrays. Give me a second. There we go. I want to go from a half to a 6. What do I have to multiply 2 by to get to 6? Well, I have to multiply by 3. So I'm going to do the same to the top, right? I want to multiply that by 3. Now, 1 times 3 is 3. So that means that, oh my goodness, my writing is terrible. 4, that means that a half as a 6th is actually 3/6, right? Because 3 out of 6 is a half, same. So now, because they're both out of 6, I can just subtract the top, the numerator, like I normally would. So how many, if I've got 4/6, take away 3/6, how many 6 do I have altogether? 1/6, all right? Whew. All right, we're gonna start moving a bit faster because I'm taking a bit long with these explanations. Evaluate the following product, leaving your answer in its simplest form. Again, same thing. Making it simplest just means I have to make sure that my final answer can't be reduced anymore. Now, how do I do this? There's 2 ways to do it. First way is I can just multiply the top, multiply the bottom, and I'm done, right? Multiplying and dividing fractions is way easier than adding or subtracting, right? There's less things you have to think about it. So when you're multiplying, just multiply the top, gives you 6. 3 times 2 is 6. Multiply the bottom, gives you 20. Now, the only thing I need to check is it in its simplest form? And the answer to this one is no. Something goes into both 6 and 20, right? Now, because they're both even, I know that 2 goes into both 6 and 20. So if I divide both the top and the bottom by 2, I get 3 out of 10, right? So that's the first way you can do it. Now, if that's the way you know how to do it and you're comfortable with that, awesome, do that. Let me show you a better way to do it. Not better way, just a more advanced way to do it, right? So if you're ready for this, do this second way. The second way of doing it is, let me erase. The second way of doing it is to look for common factors in your fractions before you do any multiplication, right? So I look at all the numbers on the top. Oh, give me a second. I look at all the numbers on the top, and I see, are there any numbers on the top that have any common factors with any of the numbers on the bottom, right? So it could be any of these 2 numbers having any common factors with any of these 2 numbers. Now, if I look at this one, 3 and 4 have no numbers that go into either of them, right? So there's no way that I can simplify there. 3 and 5 also don't have any numbers that go evenly into each other, right? Common factors of 3 is 1 and 3. Common factors of 5 is 1 and 5. No common factors there. But if I look at the 2 and the 4, there is a common factor. Something goes into both 2 and 4. What's that number? 2 goes into 2 and 4. So I can actually cancel out here. I can actually do the cancellation. I can do the simplification here. I can say, okay, 2 and 4 have a common factor of 2. I'm going to divide the top by 2, divide 2 by 2, giving me 1. I'm going to divide the 4 by 2, giving me 2. And so now I don't have 3/4 times 2/5. I now have 3 over 2 times 1 over 5. And now when I do this multiplication, 3 times 1 is 3, 2 times 5 is 10, and notice that I get the answer straight away. So if you can, I strongly suggest that you cancel out your common factors in the question before you do any multiplications. It just, when you get to really big numbers, that's a more efficient way to do it. All right. Geez, I'm taking ages. All right, keep moving, let's go. All right, evaluate the following divisions, leaving your answer in its simplest form again. So, having a look here. Now, someone tell me, what is the rule for when you divide two fractions? Does anyone know what the rule is? All right, you ready? Well, the one that I know is KCF, right? We don't ever like to divide two fractions. What we want to do is we want to change this division into a multiplication. And so we use this acronym, keep, change. Oh my goodness, my writing is terrible. Flip, right? What does that mean? It means you keep the first fraction. You don't do anything to it. You just leave it exactly the same. You change the division sign into a times. And then the last part is you flip. So oh, what happened to my P? You flip the second fraction, making the top go to the bottom and making the bottom go to the top. So it goes 15 over 18. Now this becomes a question like we just did before, multiplying two fractions. This becomes exactly the same. So what I'm going to do now is I'm going to very quickly cancel out any common factors. So do I see any common factors in the 12 and the 20? Yeah, I can actually see a common factor of 4. 4 goes both into 12 and 20. So 12 divided by 4 is 3. 20 divided by 4 is 5, right? Now I look again, are there any common factors? I can mix and match any number from the top with any number on the bottom. I'm going to do 15 and 18 just to do that one first, right? So any common factors in 15 and 18? Yeah, 3 goes into both of them. 3 goes into 15 5 times. 3 goes into 18 6 times. And now I'm going to keep looking for common factors, right? So are there any common factors between 3 and 5? No. Any common factors between 3 and 6? Yeah, there is actually. Common factor of 3 goes into both. So 3 goes into 3 once. 3 goes into 6 twice. Any other common factors? Let me have a look. Any common factors between 5 and 5? Yes, 5 goes into both of those, right? And they both goes in both of those once. So notice that in bigger numbers, this canceling out is way quicker and easier than doing what is 12 times 15, trying to figure that out. What is 20 times 18, trying to figure that out, and then trying to cancel from there. It gets crazy. The number's too big, right? So now I just have to go 1 times 1 is 1. 1 times 2 is 2. And my answer is a half, and I'm done, right? So this is probably one of the hardest fractions questions you're going to get in year 7. But now you know how to do it. Okay, so let's keep moving. Now, just in case you're looking at this going, oh my goodness, this was way too quick. I'm not catching any of this. All of this will be recorded. And if you jump onto the Mathspace Academy website, you'll be able to come back and you'll be able to view this as well. All right, last question. A cake recipe used the following ingredients: 20 grams of eggs, 80 grams of sugar, 100 grams of butter, and 200 grams of flour. Now you have to scroll down to the next part, right? Sorry if you missed that. Write what fraction of the cake is made from flour in its simplest form. Well, I know that 200 is the amount of flour, 200 grams is the amount of flour that we have. The next thing I need to figure out is, well, what is the weight of all the ingredients combined together? Because that's going to tell me what fraction of the cake is made out of flour. I need to know how much flour out of the total, right? So the total is going to be 200 at 100, which is 300. add another 80, which is 380, add another 20, which is 400, right? So the whole cake is 400 grams worth of stuff. So my answer has to be 200 out of 400. But now you're telling me, wait, that answer's wrong. It's wrong here. And the reason why it's wrong is because it's not in its simplest form. So I've now got to go, okay, what's the highest common factor in 200 and 400? Well, I know that 100 goes into both. I know that 2 goes into both, but neither of those are the biggest, right? I could do it step by step, but I know that actually 200 goes into both 200 and 400. 200 goes into 200 once. 200 goes to 400 twice. And so your answer is, ta-da, a half. All right. So that was the quiz. I hope you had a bit of fun there. And well done, by the way, to, who was it? Someone got it all completely right. Yam absolutely crushed it. Oh, and I don't know how you say this word. Akai, I don't even know. And well done to everyone else who participated. Remember that if you found any of those questions hard, then please go back into Mathspace and have a look at some of those questions in Mathspace to practice. All right. Now, if people are not doing well in this chat and people are just spamming, look, we're just going to turn off the chat. So look, I'm going to turn off the chat for a couple of minutes. And maybe when Yaz feels like she is, feels like it's ready to turn it back on, we'll do that. All right. So, Yaz, you just want to try and turn off the chat. People are still talking to me apparently. Okay. So, what I'm going to do is we're going to now watch a video. So the rest of the way the rest of this lesson is going to work is I've got a video lined up. That's going to take about 5 minutes. And then we're going to do some questions in Mathspace. And then at the very end, I've got another puzzle for you guys to show me to hand in for next week. Now, let's have a look. Let me share my screen again. We're going to watch a video. And this video has to do with fractions. All right. Now, it's a bit not directly related, but I thought it was pretty cool. Some big ideas here. Have a listen. Let me just turn on the sound. This might be very loud, so just be aware that you might need to turn your sound down. All right, you ready? Let's go.
This is Zeno of Elea, an ancient Greek philosopher famous for inventing a number of paradoxes, arguments that seem logical but whose conclusion is absurd or contradictory. For more than 2,000 years, Zeno's mind-bending riddles have inspired mathematicians and philosophers to better understand the nature of infinity. One of the best known of Zeno's problems is called the Dichotomy Paradox, which means the paradox of cutting in two in ancient Greek. It goes something like this. After a long day of sitting around thinking, Zeno decides to walk from his house to the park. The fresh air clears his mind and helps him think better. In order to get to the park, he first has to get halfway to the park. This portion of his journey takes some finite amount of time. Once he gets to the halfway point, he needs to walk half the remaining distance. Again, this takes a finite amount of time. Once he gets there, he still needs to walk half the distance that's left, which takes another finite amount of time. This happens again and again and again. You can see that we can keep going like this forever, dividing whatever distance is left into smaller and smaller pieces, each of which takes some finite time to traverse. So, how long does it take Zeno to get to the park? Well, to find out, we need to add the times of each of the pieces of the journey. The problem is, there are infinitely many of these finite-sized pieces. So, shouldn't the total time be infinity? This argument, by the way, is completely general. It says that travelling from any location to any other location should take an infinite amount of time. In other words, it says that all motion is impossible. This conclusion is clearly absurd, but where's the flaw in the logic? To resolve the paradox, it helps to turn the story into a math problem. Let's suppose that Zeno's house is 1 mile from the park, and that Zeno walks at 1 mile per hour. Common sense tells us that the time for the journey should be 1 hour. But let's look at things from Zeno's point of view and divide up the journey into pieces. The first half of the journey takes half an hour. The next part takes quarter of an hour. The third part takes an eighth of an hour, and so on. Summing up all these times, we get a series that looks like this. Now, Zeno might say, since there are infinitely many terms on the right-hand side of the equation, and each individual term is finite, the sum should equal infinity, right? This is the problem with Zeno's argument. As mathematicians have since realized, it is possible to add up infinitely many finite-sized terms and still get a finite answer. How, you ask? Well, let's think of it this way. Let's start with a square that has area 1 unit. Now let's chop the square in half, and then chop the remaining half in half, and so on. While we're doing this, let's keep track of the areas of the pieces. The first slice makes 2 parts, each with an area of 1/2. The next slice divides one of those halves in half, and so on. But no matter how many times we slice up the boxes, the total area is still the sum of the areas of all the pieces. Now you can see why we chose this particular way of cutting up the square. We've obtained the same infinite series as we had for the time of Zeno's journey. As we construct more and more blue pieces, to use the math jargon, as we take the limit as n tends to infinity, the entire square becomes covered with blue. But the area of the square is just 1 unit, and so the infinite sum must equal 1. Going back to Zeno's journey, we can now see how the paradox is resolved. Not only does the infinite series sum to a finite answer, but that finite answer is the same one that common sense tells us is true. Zeno's journey takes 1 hour.
Alright. Now, a little bit random, but I thought it was pretty cool. And if you managed to catch any of that, there's some really high level maths in there. Go explore Zeno's paradoxes if you're interested in that kind of stuff. Okay, we are going to jump into Mathspace. And someone's asked in a question, is there some kind of ID to get into Mathspace? The answer is yes. If your school has signed up to it, or if you'd like to get it yourself, you get an ID kind of that way, some login details that way. Otherwise, yeah, if you don't have Mathspace, you're gonna have to look at trying to get it somehow. At the moment, it is, if you want to buy it individually, you can. Otherwise, your schools can get it for free if they want it. Okay, let's jump into some Mathspace. Here we go. All right. So here's my fractions one. We're going to do a couple of questions. Now, in this particular set here, I know that there are heaps of questions. We're not going to do all of them. I'm going to maybe pick out 5. I might talk through a couple, see how we go. Okay, so consider the shaded bars below. I've got 1, 2, 3, 4, 5 shaded bars. I've got to figure out, write the number of shaded bars as a mixed number. Now, we just very quickly, what is the difference between a mixed number and anything else? Well, a mixed number, remember, has whole numbers and fractions together, right? That's a mixed number. An improper fraction is when you don't have any wholes and you kind of chuck all the wholes on top of the fraction and make the fraction bigger than the bottom. So we're going to do a mixed number. So I'm just going to figure out how many little bars is this whole split up into. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. And out of those 9, there are 1, 2, 3, 4, 5. So that means that this bottom section is 5/9, but I've also got 1, 2, 3, 4. So I've got 4 holes and 5. Oh, I don't want to do that. 4 holes and 5/9. Easy. What is it as an improper fraction? Well, how do we turn this into an improper fraction? Remember that what I want to do is I want to change 4 holes into something out of 9, right? And so the question is how many ninths make up 1 hole? Well, 9 ninths make up 1 hole, right? Because 9 fits into 9 once. So if I've got 4 holes, then all I have to do is go, okay, well, 4 times 9 is 9, 18, 27, 36. So that means 4 holes is the same as 36 ninths, right? And you know that 36 divided by 9 is 4 as well. So I've got 36 ninths as my 4 holes, but I've also got this extra 5 ninths that I need to take into account. So that means 4 holes and 5 ninths is the same as the 36 plus these 5/9, which is going to be 41/9. All right, so I'm going to just type that in. And away we go. Boom. All right, let's have a look. I'm going to skip this one. Let's go to another one. We did that one in the other quiz. All right, here we go. Rewrite 9/4 with a denominator of 20. All right, denominator means bottom number. So I'm going to give you 30 seconds. Can you please, on a piece of paper, write down for me 9/4 and turn that into an equivalent fraction. Instead of it being a fraction out of 4, make it a fraction out of 20, right? Go, 30 seconds. Type the answer into the chat when you're ready. All right, let's have a look. So 9/4 is the same as, well, I got to figure out, okay, how do I go from 4 to 20, right? Because whatever I multiply the 4 by to get to 20, I'm going to do the same to the top. So 420, we're going to multiply that by 5, which means that we've got to multiply the top by 5. I don't know why this is cutting out there. 9 5s are 45, so it's 45 out of 20. Well done. Heaps of people had the right answer there. 45 out of 20. Boom. All right, let's skip through a couple more. All right, 2/3 times 21/5. Oh, can anyone do this one? We talked about this one in the other one, in the quizzes. What should it be? Now, remember, Mathspace wants all the working you can have. So, you don't need to simplify first if you don't want to. You can just go straight away and multiply and then simplify. You could simplify first if you want, doesn't really matter. I am going to simplify first in this one, actually. Sorry, I was just trying to buy time, but I forgot to tell you to actually try it yourself. Let's go. Let's do this together then. So I'm looking for any common factors in the top. So out of the 2 and 21, with seeing whether they have any common factors with the 3 and the 5 on the bottom. 2 and 3, there's nothing common in both. 21 and 5, there's nothing common in both. There's actually nothing common in the 2 and the 5 either. So can't cancel any of those out, can't simplify any of those. But the 21 and the 3 have a common factor. In 21 and 3, 3 goes into both. So 3 goes into 3 once, and 3 goes into 21 7 times. So now all this does, it just makes it much easier for when I multiply. I can go 2 times 7. 2 times 7 is 14. Then on the bottom, I can go 1 times 5. And that's the answer in its simplest form. I don't need to do anything else. So 14 out of 5. Let's see if I'm right. Hooray! Okay, last one. Let's find one more. Order of operations. Let's do a worded question. Which one should we do? Okay, let's do this one. Ready? At the Easter show, Luigi spends 2/8 of an hour visiting chickens and 2/5 of an hour visiting alpacas. Alpacas are the best. How much time does he spend visiting animals? Now, remember, whenever you're doing a worded question, remember to always decode what the important information is and what the key words are. So I know that he spends 2/8 of an hour visiting chickens and 2/5 of an hour. So the numbers are important here. And the question is really asking how much time does he spend visiting animals. So if I want to find the total time, I just got to add these two bad boys together. I've got to go 2/8 and 2/5. And when I add them together, remember, I can only add fractions that have the same bottom number. So because they're in 8s and 5ths, I can't add them together straight away. I have to change them. What can I change them into? The easiest one is going to be the lowest common multiple between 8 and 5. And in this case, I think it's 40. There might be a small one. Is there a small one? I don't think so. You can do your 8 times table, 8, 16, 24, 32, 40. I can do my 5 times table, 5, 10, 15, 20, 25, 30, 35, 40. So there is no number in my times tables between 8 and 5 that is the same, that's smaller than 40. So 40 is my smallest. How do I go from 8 to 40 to change that into an equivalent fraction? Well, I'm multiplying that by 5. So I go 2 times 5 is 10, right? When I multiply that by 5. Why is this not working? right? And then I've got to go 5 times something gives me 40, and that's 8. So 2 times 8 is 16, right? So now that my fraction's both in 40ths, I can add the numbers at the top straight away. And so 10 and 16 is 26 out of 40. All right, so thanks for working along with me. We're gonna just quit out of this one here. And we're into our last part. So last couple of minutes this is my puzzle time. You ready? Now, puzzle time. I am going to quickly, I don't have my puzzle here. Let me quickly get it up. How do I get this to myself? Okay, I'm gonna have to do something. All right. So what we're going to do today is a magic square. Now, a magic square is something that looks like this. How do I get on my whiteboard? Give me a second. Okay. So this is a magic square. How do I clear this? There we go. All right. A magic square is a square with the same amount of columns and rows. And what you have to do is you have to put numbers into this square so that whatever numbers you put in, the numbers across each row, each column, and each diagonal adds up to the same number, right? Now, this time, our magic squares are going to be using fractions. So what we're going to do is we're going to say, you have to put the fractions from 1/2, 1 whole, 3 halves, where is it? 2 wholes, 5 halves, 3 wholes, 1, 2, 3, 3 halves, 4 wholes. Oops, how do I get rid of this? So I want you to put these numbers into this magic square so that, oopsie daisy, so that they all add up to the same number. So let me show you what I mean. Give me a second, I'm just struggling here a little bit. What's this one? This one's 5 halves. No, it's not. 7 halves, sorry. And then this is 8 halves, 9 halves, okay. So, for example, if I put in a 2 here, right? And let's say I put in a 5/2 here, and I put in a 1/2 here. Okay. What that would mean is when I add that row up, 5 halves, add a 1/2 is 3 wholes. 3 wholes add 2 wholes is 5. So this row adds up to 5. Now, the every other row and column that I do it now has to add up to 5 as well. So I might say, okay, well, I might put in a 1.5 here. And if I can't use 1.5, I've already used it. You can only put the numbers in once. Silly me. So I'm going to put in a 2.5 here. I don't have a 2.5 because that is 5 halves. Oh my goodness, I'm making a mess of this. Let me do it. I can't put a 2.5 in there. Let me put in 3 on 2. So if I put in 3 on 2, wait. All right. So that means 3 on 2, that's 1.5. 1.5 and 2 is 3.5. So I've got to figure out what number fits in here to get me up to my 5 that I got up to before. So 3.5, I need another 1.5, which is 3 on 2. So it means this already doesn't work, right? I'm just showing you an example of what you should be trying to do. So I'm going to give you a target number for this one. And let me just figure out what this target number is. I've got it written down somewhere. Give me a second. This number is, now I've actually made up a worksheet for you, and I was meant to show you the worksheet, but I didn't have it on this computer. The target number for this one is actually, you have to make all the numbers add up to 3 on 2. right? So every row, every column, every diagonal has to add up to this number, okay? Using the fractions that I've, actually, no, I've given you different numbers. I've got to show, I've messed this up completely, but I've got to show you what the sheet is. Yaz, do you by any chance have that sheet, and can you put it up on the screen for us?
Yes, I can. 1 second, I'll just share my screen.
All right, Yaz is going to show you the actual puzzle sheet because I messed that up royally. Let's have a look. I'm going to stop sharing my screen.
Okay, can we see that?
Okay, here we go. So this sheet is going to be put up onto the Mathspace Academy website from, I think, maybe give it 24 hours, so maybe from tomorrow onwards. So essentially, just to show you again, I should have done this from the start. All of those fractions that I've written at the top have to fit into the 9 squares that are in those boxes, and all of those must sum, each column and row and diagonal must sum to 3 on 2. The even harder one is down the bottom, is all of those fractions down the bottom have to fit into that 4x4 grid, right? And sum to 34 on 3. So can you please download this, or if you want now, for now, because this is not going to be ready for another day or so, get the key information for this now, work on it, and at the top, if you scroll to the top, Yaz, you can actually, once you've done it, got a solution, take a photo of it, scan it, whatever you want to do, send it into competition@mathspace.com.au, and I'm trying to figure out whether I can give someone prizes. I'm not sure if I can yet, but there is a possibility of having a prize. So what I might do is randomly select 1 or 2 people's solutions, see if they're right, and if they're right, they might get a prize. So what is that prize? I don't know. Could be anything. I haven't really decided just yet. But take that information down. Now, Yaz, just leave that up on the screen. And so that'll give you a chance at doing this puzzle earlier. So I'm going to leave this last minute or so for anyone who's got questions. I'm going to check the Q&A. If you've got a question for me now, write it in. Okay, someone said my school's going to start next week. Sure. This is only a supplement. This isn't meant to replace your normal class, so go and do what you have to do. What is the prize? Don't know. I've still got to think about it. And how many prizes? I don't know. We haven't sorted any of that out. But think about it. There are how many people? There are 60 people here now. So you've got a pretty good chance, if you got the right answer, you've got a pretty good chance of winning. 1 in 60. Any last questions? How will the competition be random? Well, I don't know any of you from a bar or soap. You're all going to be putting it into this. You're all going to be sending me your answers. I'm just going to pick someone completely at random. How do we download this PDF? This PDF will be uploaded to the site, to the Mathspace Academy website, probably tomorrow. So just look out for that. Yes. So when you go to the Mathspace Academy website, it's not there yet. It's going to be up there probably from tomorrow onwards, right? So just have a look at that. When can I see the recording? Again, give us about 24 hours. So check again, maybe 2 or 3 days later. And you'll probably find it up on the Mathspace Academy website as well. When you click on Year 7, there's a whole pile of recorded sessions there. So how do you send your answers? Fill out the worksheet. Either take a picture of it or scan it, and then send it back to the email address competition@mathspace.com. And yeah. So how do you send your answers? You need to either, you can, if you want, by the way, use the worksheet. You don't have to. You could potentially just take this question, write it out on a piece of paper, take a photo, send it in to me. It doesn't have to be this worksheet. Whatever it is, you send your answers by sending an email to competition@mathspace.com.au. Okay. If you don't have Mathspace, just means you can't do the working in Mathspace. You can't practice it there. You don't have to have this. You don't have to have Mathspace to enter this competition and send me through the answers for this problem, for this puzzle. Okay, if you want Mathspace, talk to your parents. They can sign you up. If they go onto Mathspace website, there's a way to sign up individually, or alternatively, ask your teachers because they can, if they're interested, they can get it for free for your school as well. Can I assign us Mathspace tasks? No, I cannot. Can we enable voice chat for next week? No, we cannot, because obviously we cannot trust people with normal chat. Definitely cannot trust you with voice chat. When is the next lesson for Mathspace? For this maths? Next week, Thursday again. Does Mathspace cost money? If you're signing up, if your parents are signing up individually, yes, it does. If your school's signing you up because of the whole COVID thing, at the moment, no. How do you upload it if you don't have Mathspace? You don't need Mathspace. You just send it to the email address. And Mathspace is not free unless your school gets it for you. Okay, so if you have any questions, I guess you can potentially send it to competition@mathspace.com.au, but really we don't want your questions in competition at Mathspace. We want your answers at competition@Mathspace. So get whatever your answer is, whether it's on the sheet or in another separate piece of paper, or if you want to do it electronically, you want to send me the answers, whatever it is, you need to send it via email at competition@mathspace.com.au. All right, I've gone 3 minutes over time. Thank you all so much for joining me today. I hope you had some fun. Hope you learned a couple of things. Stay safe and let me know if, I hope you join us for next week. I'll announce the winners in next week's sessions as well, okay? Have a good day. Now I'm gonna stick around in the chat just in case you got anything else you wanna talk to me about, but officially, the session ends now. Have a good day, everyone. Have a good week. See you later.